Hey guys, welcome to another networks lesson on critical path analysis. And to do this lesson, you should have some prior knowledge in networks. Preferably, you have done the tutorials on minimal spanning tree and shortest path algorithm before you start this critical path analysis tutorial. So what is critical path analysis? Well, it is a form of analysis that is used on networks primarily for project planning. So if you have a major project such as building a house or building a freeway or something like that, usually you have a lot of activities that you have to complete, and you have certain activities that must be completed in order to complete the other activities. And let's use this table here as an example. It doesn't really matter what kind of project it is. Okay, activity A, activity B, these are just the symbols representing different activities. And for example, we can just make it up whatever activity is represented by each alphabet. So for example, we can say A is preparing breakfast. B could represent eating breakfast, and C could represent reading emails. So this could be someone's morning routine. Okay, so as soon as they wake up, they're going to prepare the breakfast. And then once the breakfast is prepared, they're going to eat the breakfast and read their emails at the same time. And so each activity, so for the activity chart, basically we list all the activities. We have how long it takes for each activity to be completed. So that could be time in minutes. And each activity also has a predecessor, which means that before A is completed, B cannot be started. So B can only be started once A is complete. And same as C. C can only be started once A is complete. D can only be started once C is complete. E can only be started when both B and D are completed, and so on. Okay, so it doesn't matter what project it is, it doesn't matter what each activity means, we just want to be able to draw the network diagram for this activity chart. So the question will say, hang on, let me just rub this out. So the question is, prepare a network diagram. Prepare a network diagram for this project or activity chart. Okay, so how do we draw a network diagram from this activity chart? Well, firstly, we're going to have a starting node. So if you have done some work on networks already, you would know what nodes are. In this case of critical path analysis, each node represents the starting point of an activity. Okay, so it doesn't represent the activity itself. The activity itself is represented using an arc. So in the beginning, at the starting point, we have activity A that we're going to start off, and it takes 5 minutes. Now once A is complete, we arrive at the second stop, and as you can see, A is now on our network diagram, so we can cross out A. And now we look for activities where A is the predecessor. So we're going to now put on B and C in the diagram. So once A is complete, we can start on B, which takes 3 minutes. And we can also start on C, which takes 2 minutes. So B and C are now on our activity, on our network diagram, so we can cross it out. And now we can see that activity D requires C as a predecessor. So we're going to put activity D on our diagram. So C is now done. So we draw a node representing activity D is starting. So basically, every time you finish an activity and you're going to start another activity, you need to draw a node. So the node represents in the ending and the start, the ending of an activity and the starting of the next activity. Okay, so D is now on our diagram, and you can see that activity E requires both B and D having completed. So what that means is, on our network diagram, we're going to have B and D both joining onto one single node, representing this node here represents the completion of both B and D. And once B and D are complete, we're going to start on E, which takes 3 minutes. So we'll cross out E, and we can see F takes 4 minutes and it only requires E. So once E is done, we're going to go to F, which takes 4 minutes. And we can see that G and H both require B and D. So both B and D are finished, represented by this node. We're going to have G running on from that, takes 6 minutes, cross that out. H takes 2 minutes. And we also have activity I requiring H. So when H is done, we continue with I, takes 1 minute. And then there is nothing else after these activities. So we arrive at a finishing point. And this is our finish. So here is our network diagram. Now once the network diagrams are complete, we then start our analysis. Now within each node, we're going to draw in, let me use a different colored pen. Within each node, we're going to draw in the earliest starting time, on the left hand side of each node, and on the right hand side we're going to draw in the latest starting time. The latest starting time. So on the left of each circle is the earliest, on the right of each circle is the latest. Now, what does that mean? Well, let's start from the beginning. At the starting point, we're starting this project on time equals 0. Right, on the 0th minute, we're starting the project. Now, activity A takes 5 minutes. So we arrive at this node on the 5th minute. So I'm going to put 5 there. And what that means is we can start both B and C on the 5th minute of this project. Now, so we're starting B and C on the 5th minute. 5 plus 2 is 7, so I'm going to get to this node here on the 7th minute. Okay, now let's have a look at this node. Now there's two options getting into this node. We can either get here via B, which is 5 plus 3, which is 8, or 7 plus 4 is 11. So are we going to put in here 7 plus 4, 11, or are we going to put in here 5 plus 3 is 8? Have a think about that. Now the answer is 11. So let me just write in here 11. Now why is it 11? Because let's say somebody is doing activity B, and this person has arrived at this node finishing on the 8th minute. 5 plus 3 is 8. However, because activity E, G and H, if you have a look at the activity chart, E, G and H, they require both activity B and D, both of the activities to be finished before they can even be started. So even though B has finished and is now standing at this node waiting, we still need to wait for D to be finished before we can continue with the network. So therefore, the earliest starting time of E, G and H is 11. Okay, so 11 plus 3 is 14, so we get here on 14. 11 plus 2 is 13. Now, the finishing point, we have 3 activities merging onto the finishing point. So either 14 plus 4, which is 18, or 11 plus 6, which is 17, or 13 plus 1, which is 14. And obviously the answer is going to be 18. Right? Now why is it 18? Because let's say G has finished on the 17th minute, while the whole project is only finished when everything is finished. So we got to stand here. G is going to stand here and wait until F is finished, and I obviously has finished by the time G has finished. So 18th minute, 18 minutes is how long it takes for the whole project to finish. Now let's do the latest starting time. So we're going to start on 0, obviously, in the beginning. And activity A is going to take us 5 minutes, so we put in 5 there again for the latest starting time. And C takes 2 minutes, so we'll get here on 7. And you might say, well, what is the point in writing the same number on both the left and the right? You'll see the difference soon. So 7 plus 4 is 11. Okay, now here is where the difference is going to come in. 11 plus 3 is 14. So we're going to put in 14. Okay, now 11 plus 2 is 13. Now here is the only node in this network where we have a different earliest starting time and the latest starting time. Now if you have a look on the finishing point, we're going to finish the project in 18 minutes, right, on the 18th minute. But we arrive at this node after H is complete on the 13th minute, and I only takes 1 minute. So what that means is when H is finished, the person who is on this line doing the activity can sit here on this node and wait until the 17th minute. So I'm going to put in the number 17 here. Until the 17th minute, and then do activity I, because I only takes 1 minute, and we will still get to the finishing point on time. So this node is actually the only node where we have a different earliest starting time and latest starting time. And you will see that for this project we have a line where from the beginning to the end, where the earliest starting time and the latest starting time have the same number. And I'm going to draw that line using a different color. So basically from here, the starting point, to here, to here, oops, to this node, to this node, to this node. Right, along this path, the earliest starting time and the latest starting time are the same. And this pink line is what we call the critical path. The critical path meaning that activities along the critical path cannot be delayed. Cannot be delayed. Right, so once we figure out where the critical path is, we can then look at the slack time for the other activities. So what is slack time? Slack time is the amount of time an activity can be delayed. So if we have a look at activity B, so slack time for B. So activity B, we're starting on the 5th minute. It only takes 3 minutes, so that means we will get here on the 8th minute, but we don't have to get here until the 11th minute. So what that means is the slack time for activity B is 11 minus 5 plus 3, which is 11 minus 8, which is 3 minutes. Alright, slack time for B is 3 minutes. Why is it 3 minutes? I'll say it again, because we are starting B on the 5th minute. B only takes 3 minutes, so we'll finish B on the 8th minute, but we don't have to have B finish until the 11th minute as stated in this note here. So therefore we have 3 minutes spare, and we can possibly delay B for 3 minutes before we start it. Now any activity that is not on the critical path will have slack time. So let's look at activity G. Again, we have 18 minus 11 plus 6. So 18 minus 17 is only 1 minute. So that makes sense because 11 plus 6 is 17. We need to finish by the 18th minute. So really, we only have 1 minute possible slack time for G. Let's look at for H and I. Let's look at I. Now, activity I, let's say we start on activity I by the 13th minute. Now, what that means is we have 18 minus 13 plus 1, which is 18 minus 14, which is 4 minutes for I. Now that is assuming that we're starting I on the 13th minute. Alright, because we start on 13th minute, 13 plus 1 is 14. We therefore have 4 minutes to go until the finishing point. Now lastly, we have slack time for activity H. And the slack time for activity H is, if we have a look at this node here, the latest time we can start on activity I is 17. So assuming that we don't get to that node until the 17th minute, we have the earliest starting time for H is the 11th minute, and activity H only takes 2 minutes. So we can possibly get here on the 13th minute, but we don't have to get here until the 17th minute. So therefore the slack time is 17 minus 13, which is 4 minutes for H. Hope you have a better understanding of critical path analysis. I'll see you again for the next tutorial.